Hello everyone. In today's class, we will discuss about a quicksort algorithm. Okay, let's consider this the input array with elements 4, 6, 2, 8, 1, 5, 7, 3. Okay, so the steps we have to follow is the first step is we have to pick a pivot element and place it in correct order. Okay, pick a pivot element and place it in correct order. That is the first step. The second step is uh, we have to find all the elements which are smaller than a pivot element and just keep them in left side of pivot. Okay, and the next step is we have to find out all the elements which are greater than pivot and just keep them in right side of pivot. Okay, these are the steps we have to follow. The first step is pick a pivot element. Okay, the pivot element we can pick any element. It may be first element, okay, or it may be a last element, or it may be any random mid element, or it may be any random element. That is a pivot element, and we have to place it in correct position or correct order. So that is the first step. The next step is check all the elements, okay, which are smaller than pivot element, and keep all those elements in left side of pivot, and find out all elements which are greater than pivot element, and just keep them in right side of pivot element. Okay, these are the steps. Okay, let's follow these steps with this example. Okay, just in this case I just am taking uh, 4 as my pivot element. That is the first element. Okay, if you consider 4 as my pivot element, right? So ideally if you want to place in the correct position, 1 2 3 4, it should go here, right? Correct. So now keep checking all the elements. Okay, is 6 is greater than pivot element? Yes, so it should go right side, right? So 6 should come here. Is 2 is greater than a pivot element? No, so it's a small, so let's move into left. 8 is greater than a right side. 1 is smaller, left side. 5 is greater, right side. 7 is greater than right side. 3 is smaller, left side. So this is the first step. So after first step, if you see, 4 is placed here, correct? So and also if you observe, we have two arrays. If you see, this is a left array, this is a right array, correct? So now all the elements which are left side of this 4 are smaller than pivot element, correct? Same way, all the elements which are right side of this pivot element are greater. Okay, we achieved this. Okay, this is the first step. With this, we have placed only one element in correct order. Correct. Likewise, we have to keep checking the left array as well as right array by using recursive approach. Correct. So if you take again the left subarray, but see, if you see left array, right array, both are not sorted, right? We have to keep following same step. That is, pick a pivot element, keep placing the smaller elements left side and the bigger elements at the right side. Same steps. So let's pick a left array. That is 2, 1, 3. Okay. So here again, 2 is a pivot element. So if you want to place correct uh, order, right? So 2 should come here. Since 1 is small, it should go left. 3 is greater, it should go right. So now 2 is a pivot element placed in correct order. Again we have to take left array, right array. Since we have only one element in left, one element at right, so if there is only one element, it's already sorted. No need to follow these steps. First, if it is having only one element, so the left side array is sorted 1 2 3, correct? Same way, let's take a right side element. That is right side array 6 8 5 7. So pick uh, the first element as pivot. So if you want to place 6 in correct, right, it should come here, right? So 8 is greater, let's move right side. So next 5 should go left because small, and 7 should go right. Okay, now 6 we place in correct order. Again, what is a left array 5, a right array is 8 7. Since there is only one element left, so it's sorted. So 5 6 are sorted. So 5 and 6. Now we have to pick now 8 and 7. So let's take again pivot as 8. So if you want to place in correct position, this is the correct position. Let's check 7 is a smallest element, it should go left. So 7 and 8. Okay. So now if you see, and then how 4 is there here. So if you observe 1, 2, 3, 4, 5, 6, 7, this is what sorted. Got it? And here the important point we need to notice is the 4 is right. This is called we have to consider as a partition index. Okay. So 4 is called as what? A partition index. Correct. And to check the left side, right, we have to check from that is, if you consider this is a low pointer, right, from low to partition index -1, and the right side, how we can say partition index +1 to the high pointer. Okay, this is the logic we have to implement while writing the code. Okay, let's understand the code now. So I'll be using two pointers, low and high pointer. Okay, and I'll be selecting pivot element as the first element. Let's see how we can achieve it. Okay, so let's take the same example, how we can write the code. So that is 4, 6, 2, 8, 1, 5, 7, 3. Okay, so we have to pick pivot element, right? So let's take my pivot element as the first. So let me take this 4 as low and 3 as high. Okay, so pivot element I have to take as E of low, that is 4. Okay, and we have to keep checking, right? So is the, as I told you, we have to place all the elements which are lesser than a pivot at left side, and the all the elements which are greater than pivot at right side, right? So let's take two variables I, and let's take one more variable here, j. Okay, so the first step is, from left side we keep on incrementing I till we find the greater than greater element than pivot element. Okay, if you find the element which is greater than pivot, we will stop the I. Okay, same way from right side we'll keep checking the element which is lesser than pivot, and okay, and we'll stop. Okay, so let's follow this process. Okay, is 6 is uh, greater than pivot? Yes. Okay, let's stop the I here. Okay, if you found any element smaller than I, let's increment I. Okay, if we found the element which is greater than a pivot, then we'll stop I value. Same way is from right side, 3 is smaller than pivot. Yes, stop it. Don't decrement the j value. Now swap 6 and 3. Okay, so if you swap 6 and 3, 3 should come here, 6 should go here, right? And remaining all elements will stay as is: 4, 2, 8, 1, 5, 7. Fine. So where is I pointing? Here, right? Where is j pointing? Here. Correct? Follow same. Pivot element is 4. Is 3 greater than 4? No. Increment I value. Okay. Is 2 greater than 4? No. Increment I value. Is 8 greater than 4? Yes. Stop I value here. Okay. And is 6 less than pivot? Okay. No. Okay. Decrement j value. Is 7 less than 4? No. Decrement j value. Is 5 less than 4? No. Decrement j value. Is 1 less than 4? Yes. Stop j value here. Now swap these two. So 1 should go here, 8 if we swap. Okay, remaining all elements stays. Okay, that is 4, 3, 2, 5, 7, 6. Okay, where is I pointing? Here. J pointing here. Okay, yeah, is 1 less than pivot? Yes, increment I value. Is 8 less than pivot? No, stop here. Okay, and is 8, okay, uh, uh, greater than pivot? Yes. Okay, decrement j value. So as soon as if you observe here, I and j are crossed here. Okay, so this is the important point. I and j are both crossed, correct? So as soon as if you found the crossing point, right? So if you closely observe, after this crossing point from 3 to 1 till here, right, these elements are smaller than pivot element, and from here, right, so these elements are greater than pivot. Okay, now we have to swap this pivot element with j. Okay, this is a j, right? Okay, so we have to swap the pivot, that is the a of low. Low is this one, right? A of low with j. Okay, so if you swap it, 1 should come here, 4 should go here. Okay, remaining elements 3, 2, 8, 5, 7, 6. Okay, this is the first step. Okay, so if you notice, uh, 4 is called partition index, correct? This is called partition index. Okay, and we have to keep following by calling a recursive function the left array as well as right array. Got it? So how we can call a recursive function? So suppose if we have a function name called quicksort of, so array name comma the low, which is the 0, comma pivot index is right, pivot index -1. Okay, this is the for left array. Same way for right array, how we can call array comma pivot index +1 from here, comma this is the high. So like this we have to call two recursive calls. Okay, so let's write the code. Okay, then we'll discuss the time complexity as well as space complexity as well. So this is my input array. Okay, so let me write a function quicksort. What I am passing my array variable, and 0 as my low, and what is a high, array dot length -1. Okay, and after sorting I want to print the elements. So let's write after sorting, sorry, so this is the result, arrays dot to string. Okay, write a user defined method that is quicksort. Let's create it. Fine. So here, right, if, so let's name these variables as low and high just for a better understanding. If low less than high, that's the base condition, right? So I have to find out partition index. That's the first step, right? For that, we'll implement a function that is a partition of. I have to pass array, comma low, comma high, correct? And once we found the partition index, I recursively I have to call, right? What I have to call quicksort. Okay, to call. Sorry guys, this is spelling mistake. Quicksort. Quicksort of. From where I have to pass array, comma low to partition index -1. Okay, that's what we discussed here, right? So this one for this left side. Okay, low to partition index -1. Okay, same way call the right side part. How we can call array, comma partition index +1 to high. Okay, this is for right side for this portion, right? 8576, correct? Done. Let's create one more method, partition. Okay, from here we need to return a partition index. Okay, so for that, first I have to take a pivot element, a pivot equals to. So let's take rename as A of low is my first element, right? Pivot. Let's take the two variables I equals to low, and let's take j equals to high. Okay, we have to keep checking, right? That is while I crosses j, right? Till whenever I crosses j, we have to keep checking. Okay, and the first step, right? While, okay, array of I, okay, less than or equals to pivot, and till we have to check till less than high, right? Okay, it should not cross I. Okay, till if I reaches till here, and j should decrement till I we can increment I value till we reach to high, that is end of the array. J we keep decrementing till we reach to the starting position, right? That is the this check. Okay, we have to increment I. Same way, one more while loop for what? For from right side, right? Array of j, if it is greater than pivot, okay, and j should greater than low. So we have to decrement j. Okay, once we found these things, right? That is the element which is greater than I, and the element which is less than j, right? So, and if I less than j, I have to swap. What I have to swap? The array I and j, correct? I and j I have to swap. Okay, and I'll write a swap function here. Okay, and once these two are completed, crossed, okay, this once these two are crossed, we need to swap one more time, right? What at this time I have to swap f low with my j, right? This is the j, correct? We have to swap af low with j, right? So for that we have to write one more after while loop. We have to write one more swap of array comma up to low comma j. Fine. So here finally we need to return j, correct? And we have to write a user defined function, that is swap function we have to write. So write a swap method, and we know logic, right? How to swap two numbers. Let's write a int temp equals to a of I, okay, and a of I equals to a of j, and a of j equals to temp. That's all. Okay, just control 50F, just format it or run the program. Yeah, this is swapped. Okay, all the elements 1 2 3 4 5 6 7 8, got it? And if we calculate the time complexity and space complexity here, we keep on no, dividing elements, right? Here not exactly half, but still we are partitioning, right? That is a log n. And every array we are iterating n elements, right? That is, so for partition, since we are partitioning, because size, the array size is reducing here, that is a log n. And again, every array having n elements, if you consider, that is space complex, sorry, time complexity is order of n log n. And space complexity, though we are using the stack space, okay, but we are not using any other space, so we can consider the space complexity as order of 1. Okay, thanks for watching this video.